Good morning, students.
Good
So
morning,
I
sir.
think morning. I think I left out a small portion, right? Volume is not done the volume portion of the question, volume of the solid, but we have to find the total surface area also. So I'm rubbing this off. Let's keep the figure. All right. And remember, we have separated the dimensions, the parameters for the three part of the figures. Remember this as a cylinder and the top part has two hemispherical ends. So for the two hemisphere on the top and the bottom, the radius are the same, right? So you don't need to copy this. I'm writing this in red. We have already done this in the previous class. For the hemisphere part, radius was how much? 3.5 centimeter, or rather this 7 was divided by 2, right? And now coming to the cylinder. For cylinder, we need two things, right? We need the radius and we need the height. So radius will be the same as this one, 7 by 2 centimeter. And height we have found out from 42, we have subtracted uh, from 42 we have subtracted 7 by 2 and 7 by 2. So we had 42 minus 7, which was equal to 35. So for the cylinder, radius was 35. Height was how much? Oh, sorry. Radius was 7 by 2, same as the hemisphere. Height was 35. Now, what you have to know is when we find out the total surface area, the total surface area will also consist of three parts. Wait a moment, I have to rub off the screen. I think it's a little wet. So, for this surface area also, we have to consider the three parts still. There are two hemispheres and there is a cylinder. So remember, when we consider a cylinder, if we consider this top part and bottom part, then we call it the total surface area. If this top and bottom are not considered, then we will call the surface area as what? Curved surface area, right? So here, this top and bottom, they're already covered by the hemispherical ends. These two hemispheres have already covered it. So we are not going to find out the total surface area for the cylinder, but we are going to find out the curved surface area of the cylinder. So when we want to find out the total surface area, it will be surface area of hemisphere, that's the top portion, plus curved surface area of cylinder, there is the middle portion right here, plus surface area of hemisphere, the bottom portion. So you all know the formula surface area of hemisphere, it's 2 pi r square, 2 pi r square. Curved surface area of cylinder will have 2 pi rh, right? So you have to add all of them together. So coming to the surface area, let's continue the solution from the previous day's class. The surface area of the surface area of hemisphere plus curved surface area. Remember the CSA, I'm writing it as short for curved surface area. So curved surface area of what? Of cylinder plus surface area of hemisphere. The three parts differently. So you know that surface area of hemisphere is twice pi r square. Right. This one also. There will be a twice pi r square. If you add them together, I'm taking the first and the last part. 2 pi r square, 2 pi r square, it's 4 pi r square. Right. They have the same radius, so no need to take radius as r1 and r2. So surface area of the first hemisphere will be 2 pi r square. Second hemisphere will be 2 pi r square. This is for the part of the two hemisphere. And Curved surface area of the cylinder, how much is it? Twice pi RH. All right, let's keep it. So we have got 4 pi r square here, 2 pi RH here. We can take a common factor between these two, right? Pi r, it's in both of them. And 4 and 2, we can take out two common factor, easy stuff. 2 and pi and r are taken out as common factor. So if I take out 2 pi r from 4 pi r square, what is left? Pi is gone. Out of the 2 r, 1 r is gone. Out of the 4, 1, 2 is gone. So we are left with 2 and r plus. So for this one, it's really visible, right? 2 pi and r is taken away. That means this h will be remaining. Okay, this is just for the formula sake. You can find out the surface area. You can put the value of r and h here. That way it becomes very long. All right. This calculation becomes a little complicated. So we are taking the formula together first, taking a small common factor, and then we will put in the value now. So put in the value. 222 by 7. R is 7 by 2. 2 into 7 by 2. H is 35. Now what you have to note here is this H, this does not represent the total height. The H part is just for the cylinder. Which part is the cylinder then? Only this part, right? So for this one, we have already found out the height of the cylinder. It was 35. You have to look it up in your notebook. Now time to do some cancellation. 2 and 2 get cancelled. 7 and 7 get cancelled. This 2 and this 2 get cancelled. What is left? There is a 22 left. Here is 7 left. Here is 35 left. Right? There's 22 here. There's 7 here. And there's 35 here. 22 into, how much is that? 35 plus 7. It's 42, right? So after multiplication, it's 84. So 4, 12, 924. So check it out. 42, 22. So this is supposed to be, this is area, right? And every unit is given in centimeter. That means when you find out the area, it will be in centimeter square, right? You have to note the steps that we are taking here. So you have to separate this consists of 3 types of figures, right? Actually, these two are the same. So you consider the hemispheres and you consider the cylinder. You have to know, in order to find out the surface area or the volume, what is needed in which type of shape. So for this hemisphere, only radius is needed. So we have it here. For the cylindrical part, we need the radius and we need the height as well. That's why I'm writing the R and H separately. And coming to the surface area, we have to work with the formula. Surface area of the hemisphere, cylinder, surface area of hemisphere. You have to remember it by heart. 2 pi r square is for this one. This 2 pi r square is for this one. And the surface area of cylinder is this one. After that, you just take out common factor. You can put the value in here also. 2 into 22 by 7 into 7 by 2 into 7 by 2 into plus 2 into, that will be very long, right, if you put it here. That's why we put together the formula first, take common factor, and then put in the value. That way it's much shorter and it's more accurate also. Less chance of making mistakes. Okay, you copy this. Then moving on. So this is a question related to ice cream. Lots of questions related to ice cream actually. There will be 2 more questions after this. An ice cream is in the form of an inverted cone. A cone looks like this, right? This is a cone. Inverted cone will look like this. This is an inverted cone upside down. So there is an ice cream which is in the form of an inverted cone. So only the cone doesn't make the ice cream, right? This is an inverted cone, and it's surmounted. There's something on top by a hemisphere of the same radius. So this is surmounted by a hemisphere like this. And the hemisphere and the cone, they have the same radius. They share the same radius. Question further say, if the radius and the height of the cone are respectively 2.1 centimeter and 8 centimeter, find the volume of the ice cream. Okay, let's draw the figure properly first. You've got the ice cream, you've got the inverted cone, you've got the inverted cone, and this is surmounted by a hemisphere. This is surmounted by a hemisphere. All right, then I'm shading the cream portion with blue ink. Let's make it red. All right. So this is the hemispherical portion, and there is a cone portion. It's better keep it without anything. And what does they do? They share the same radius. So they have the same radius. The radius is the same for the two. Question further say, if the radius and height of the cone are 2.1 and 8 centimeters. Radius is how much? 2.1. Height is this portion right here. This is how much? This is 8 centimeter. All right, then let's draw them also. R is how much? 2.1 centimeter. H is how much? 8 centimeter. Question wants us to find the volume. Okay, similar to the previous question, it will have two parts, right? The hemispherical portion and the cone portion. You just have to add the volume of the cone and the volume of the hemisphere. Easy as that. Okay, then let's see solution. So you say here for the hemisphere. You have to write the parameters separately. For the hemisphere, how much is the radius? 2.1 centimeter. We only need the radius, right, for the hemisphere. For the cone, we need three things actually. One is the radius, one is the height, the third one is the slant height. This part right here. Slant height is required if you want to find out the surface area. But the question asks only the volume. So we will not find out the slant height because it's not required. All right. So for the cone, you write down radius is 2.1. It's same as that of the ice cream cone, right? It's same as that of the hemisphere. How much is the height? Height is 8 centimeter. I don't think this will be visible. So time to find out the volume of ice cream. How much is it? It will be volume of hemisphere plus volume of cone. Volume of hemisphere is how much? What's the formula? 2 by 3 pi r cube. What about that of the cone? What's the formula? 1 by 3 pi r square h. Now, again, as we have done before in the previous question, it's very easier. It's easier to take out the common factor first. Say the 3 denominator, we can take out this common factor. Pi can be taken as common factor. R square here, r cube here. The smaller one, you can take out common factor. Smaller one is r square, right? So to take out the common factor, it will be pi r square and 3 denominator. We are taking them out as common factor. What is left then in the first one? 2 is remaining. Out of the r cube, r square is taken out, so there must be only 1 r remaining. So 2r plus. From here, what are taken out? Pi is taken out. R square is taken out. 3 is taken out. That means only h is remaining, right? So put the value of h. Time to substitute the value. 22 by 7 into r square is how much? 2.1 into 2.1 divided by 3. Now we can put in the value in here also. Instead of r, it's 2.1. Instead of h, it will be how much? It will be 8. So 2 into 2.1 plus 8. Whatever can be cancelled, we are going to cancel out later on. So for now, we just copy it to here. We will have 3 more steps for the calculation. Don't forget to draw the figure. And the r is 2.1, h is 8 centimeter. You have to put it on the side. I'm rubbing this off. I'm just taking up the last step above. All right. So you know that 21 we can express it, this 2.1 we can express it as 21 by 10, right? There is one decimal point, so there is a zero here. So express this, we will have 22 by 7 into 21 by 10 into 21 by 10 divided by 3. You can multiply this, 2 and 2.1, it will be 4.2 plus 8. Do cancellation, 7 3s are 21, 3 7s are 21. Okay, this part is the numerator, 1 2 3 4, these are the denominators, you have to understand that. Okay, that's why we can cut the denominator and numerator. So whatever is left, you keep it. We will have 22 into 3 into 7 by 10 into 10. And into, we can multiply this. We can add these two together. Add and multiply all this 1, 2, 3, 4. Denominator, how much is it? 10 and 10 will be 100. 10 and 10 is 100, right? So multiply the numerator part. So this is going to take long, so just let me multiply on the side, 22 and 21 and 12.2. So numerator we will have 5636.4. If there is a 20 here in the denominator, you can move the decimal points 2 more steps, 2 more places you can move. So we will have 56.364. Now remember, we are finding out the volume, right? So you put centimeter cube here. Okay, that's it for this question. You finish copying. Moving on then, next question. Okay, so this is a little long, question number 5. So important thing is to draw the figure first. Okay, you have to have it in your understanding what the question is saying first. It says a cylindrical vessel of radius 7 centimeter. We have got a cylindrical vessel. Oh, let's draw it first. A cylindrical vessel. This is a radius 7 centimeter and height 30 centimeter. Okay, let's make the height as 30 centimeter. Then coming to the next sentence, it says, how many ice cream cones? This can is full of ice cream. This cylindrical vessel is full of ice cream. This is top to bottom filled with ice cream. So let's say you are a seller, you are an ice cream seller. You have to take out the ice cream from here and then scoop to another cone, right? So question 1, how many ice cream cones, each of radius 3 centimeter and head height 8 centimeter with hemispherical tops, can be formed with ice cream from the vessel? So ice cream from here, we have to fill it into a smaller cone. The smaller cone has a radius 3 centimeter and the height is how much? 8 centimeter. And this has a hemispherical top. We have a hemispherical top. Let me draw it with red. Hemispherical top. The hemispherical top would have a same radius, right? So how many of these can be formed from this? Okay, consider like this. Very easy one. You have to understand the concept first. We have a tank. We have a large tank here. We have a large tank. This large tank, it has a capacity of 1000 liters. From this, we run a tape and then we have to fill 2-liter bottle. Okay, this bottle is of 2 liters. This bottle, it can fill with 2 liters. From the 1000 liter tank, how many 2-liter bottle can you fill? How many 2-liter bottle can you fill from this 1000 liter tank? Simple, you have to divide them, right? The volume of the big tank, 1000 liters. The volume of the small bottle, 2 liters. We will cancel them, we get 500. So from the large tank of 1000 liters, we can fill 500 bottles of capacity 2 liter. So bearing that concept in mind, what we have got here is we have got an ice cream can here full of ice cream. We don't know its volume. We can find it out, right? If we know the radius and the height. So this ice cream can has a certain capacity. From this, we have to fill ice cream cone, which has a smaller capacity. How many ice cream cones can be filled? In the previous one, the volume of the large tank and volume of the small bottle, we divide them, right? Likewise, what we are going to do here is we are going to find out the volume of this large can. We're going to find out the volume of this small ice cream cone. And then we will divide them. That way we are going to find out how many ice cream cones we can fill from this large can right here. Okay, so this is the first figure. This is the second figure. So let's find out the volume of the first one. Okay, so here start the solution for the cylindrical tank, for the cylindrical vessel. How much is the radius? 7 centimeter. Height is how much? 30 meter. Let me write R1 and H1. Why? Because we will have another height here. So in order not to confuse, I'm writing R1 for the radius of the cylindrical vessel. H1 is the height of the cylindrical vessel. How much is the volume? Volume of the vessel, it will be, you know the formula for volume of a cylinder, right? Pi r square h. So 22 by 7 into 7 into 7, h is 30. Cancel them. So what is left? 22, 7, 30. So we get 21, 21 2s are 42. So 2, 6, 4, 0. So 4, 6, 2, 0. So this much in terms of centimeter cube. All the units are given in centimeter, right? So I made a mistake here. It should be centimeter. So the volume of this large can right here we have found out to be 4,620. Now this small ice cream cone, you find out the volume. So you say here, you mention here for the ice cream cones. Remember, ice cream cone has two parts, right? It has a hemispherical part and it has a conical part. So here you have to mention for the hemisphere, for the hemispherical part. Let's write the radius as R2, which is equal to 3 centimeter. Height is how much? Sorry, we don't need the height for the hemispherical part. We will have for the conical part, H2 will be how much? 8 centimeter. Why am I taking the height is H2? Because height H1, we have taken it for the cylindrical vessel, right? So you find out the volume of this ice cream cone. So let's do on the side. Volume of ice cream cones. It will be, you have to add the volume of hemisphere and you have to add the volume of cone. What's the formula for volume of hemisphere? Let's write it here. Volume of hemisphere is 2 by 3 pi r cube. Volume of cone is 1 by 3 pi r square h. Okay, copy up to here. We will continue 1, 2, 3 more steps for further. Copy up to here first. So these questions, this can be given a 5 marks. All right. In the previous board exams, what the board did was they took 5-mark question from the last exercise, 12.6 actually. So this one has something called frustum of a cone. So you take a cone here, you cut off. You cut off here, so the part you are going to get will look like this. The shape of a bucket, right? The shape of a water bucket. But this part was removed according to your latest syllabus. So you may expect such long questions as carrying 5-mark questions from mensuration. One 5-mark question is compulsory. Okay, one 5-mark question, one 4-mark question, another 3-mark question. It will be compulsory. For now, you focus on the learning the concepts. Okay, understand the concept first. The things that will give you mark, we can study it later on. We can discuss it later on. Which one carries more weight in terms of mark? Which one carries less mark? We can discuss it later on. But for now, try to grasp the concept first. So yeah, I'm keeping this value on this side, and let's rub this off. Let's bring this up. So the value of this R2 is 3, H2 is 8. So yeah, don't just write R, okay? Write R2 here, R2 here. The hemisphere part and the cone part, they have the same radius. So first of all, let's take common factor first. You can take out 1 by 3 pi and R2 square. We have already done this, right? I don't think we need explaining further. We have 2R2 square left. Sorry, just R. 2R2 plus H. So everything from this 3 here, this pi here, this R2 square, it's taken out. So one of the R2 is remaining because there was a cube here. From here, everything is taken out except for H. All right, then let's put in the value. R2 is 3 centimeter, right? We have it here. So we will have 1 by 3, 22 by 7, 3 into 3, 2 into 3 plus 8. H2. Okay, we can cancel 3 and 3, this one. The rest of them, we cannot cancel it further, right? But finish this portion. 2 3s are 6, 6 plus 8 is 14. So we will have 22 by 7 into 3 into 14. Can cancel this now. 7 2s are. So we have got 22 into, sorry, 3 2s are 6. How much is it? 132. Now, I'm moving this upwards. This is just multiplication addition. Okay, you can check it later also. If you get confused, you can just check it later on. You are just putting in values actually. 1 by 3 here, pi here, R2 square here. R2 is, since there is a square, we are putting it 2 times, right? So final value is 132. Look, for this one, the volume is 4620. For this one, how much is the volume? 132 centimeter cube. As I told you earlier, from a big tank of 1000 liters, if you are draining this into small bottles of 2 liter, how many bottles will you get? You have to divide the 2 volumes, right? Here also, if I want to find out how many of these can be made from here, you have to divide these 2. So you mention here, therefore, number of ice cream cones which can be made is equal to, you divide the 2 volumes. You have to understand why we are dividing these 2 volumes. Okay, so 4620 centimeter cube by 132 centimeter cube. Units will get cancelled. We're just finding out a number, right? Now you can divide this with 11. 11 4s are 44, 11 2s are 20, 11 1s are 11, 11 2s are 20. 3 1s are 3, 3 4s are 12, 3 4s are 12. 270, 2 2s are 235. Okay, now after cancellation, as you can see, we have got 35. Now the number of ice cream cones. The question asks how many ice cream cones can be formed from the vessel, right? From this big one. So after division of the volumes, we get the 35 ice cream cones can be made. Okay, copy up to here and let's finish today's class. If I take one more question, it will take at least 20 minutes. So better finish here.